Go for it.
So I've been a software developer is kind of the general term I'd use for a bit over a decade now, and I've been lucky enough to be able to build a few different types of things. I've done games and websites and systems and all kinds of stuff. And when you've been doing software of different kinds for a few years, 3 to 5, you start to realize that pretty much everything in a computer is all the same thing. It's all just different layers and it's all kind of the same stuff. So this is a knowledge remix from that perspective. And this is me really just having been going through for about a fortnight, just checking out Solidity, how it works as a language, how it fits into what a blockchain is and how that operates in the context of everything else I already know about computers. So it's quite technical. Really, I intended this talk for people that had done a bit of programming before, probably, you know, the C programmers, Java programmers, guys with a bit of low-level experience. But even if you're not a technical person, I hope you'll come out of this with some new understanding of how computers work, maybe, and how the blockchain works and how it kind of fits and how it's the same and how it's different. So there's an awful lot to get through. I'm going to kind of run through a few preface sort of things. I'll go through just sort of, you know, the basics of the language in terms of how you store data and move it around. But I'll jump through that quite quickly because this is all online, and I figure if you are really keen to get in, this sort of doubles as a bit of reference material now. So you can dig into it more on your own time if you want to. So yeah, and a few conventions before we get started because there's a lot of information, and I'm going to go quite quickly because I've got 80-odd slides to get through. But the main ones you want to care about are oranges, blues, and reds. And so oranges is kind of describing objects within systems, blues are describing behaviors and things that happen, and reds are describing things that may not necessarily be trustworthy. And while I was doing this, I ended up sort of building a syntax highlighting package for Solidity because there wasn't a good one. So you can install that as well if you want to make Solidity code look good in a web browser. And there's a couple of conventions. The important ones are caveats and suggestions because there's a lot of weird stuff, so I'm going to put little red tags around it. And suggestions are just kind of my own suggestions based on what seems like a good idea to me at this point. Take them as you will. And the others are there for subsequent updates after this in case I get anything wrong. So let's start. So same concepts, different environment, and I guess the big key thing here is that Ethereum is a very low-level system. And you can kind of think of the blockchain and all the pieces in it in the same way that you can think about all the bits in a normal computer. So you've got your blocks in the chain, which are just kind of ordered chunks of data, and the blockchain is kind of a lot like the RAM in your computer, and it's also kind of a lot like the hard drive. It's where all the stuff gets stored. And so then you've got the EVM, which is the Ethereum virtual machine, which is the processor that does all the thinking that kind of runs on top of that. And every time the miners make a new block, the EVM runs a bunch of code, which is all the contracts that you've defined, and they take in their data from the block that was just there, and then they spit out the data for the new block, and then next step of the program sort of thing. So the EVM in this case is very much like the JVM in Java, which is sort of the virtual computer that Java runs on, and it's also very like the actual physical computer that you have inside of this laptop or your desktop or your phone. They're all just computers, CPUs. And the contracts you can think of in the same way as, you know, a compiled piece of bytecode running in a system. Solidity as a language you can think of in much the same way as C++ and Java and C and C# and all of those. Solidity compilers are much like all of your C compilers and Java compilers. Contracts are much like classes. Deployed contracts are much like objects. And deployed contract addresses are much like memory addresses, and they're kind of a bit like files as well because they're always there because they're on the blockchain. And it's sort of important to note that there's no real need for RAM and hard disk anymore. There's no such thing as I/O anymore in this system because you don't have the need to read stuff off a disk and manipulate it and put it back down because it's all just there. And we'll get to that in depth later. And I want to mention also before we start that Solidity is not necessarily the end all. Serpent and LLL were kind of the earlier versions. Serpent looks a lot like Python. LLL is a Lisp. So it's just, you know, lost in stupid parentheses, as people like to say, a bunch of brackets, and it's very close to assembly. So you can play with all those as well, and no doubt there'll be other languages people might write later that will also compile down to the contract bytecode to run in the virtual machine on Ethereum. And there's certain weirdnesses that come with that, as we see later. Words of caution. This was something I read after the DAO hack on a blog. Do not develop Solidity contracts without a reasonable grasp of the underlying Ethereum virtual machine execution model, particularly around gas costs, which made me go, oh, should I be doing this? Yeah. So, but I think I should be doing this, and I think we should all be doing this, because unless we're looking into these things and understanding them, then we're not going to be experts, and people need community members to be experts. So that's what we're here for. And just a little bit of code like joke there for all the huge nerds. Learn more languages that are low level, basically, and if you only know JavaScript, you'll be scared. Bit of a litmus test. Here's just a little bit of JavaScript, and how big is that array going to be in the brain of the computer after that statement's finished? And the answer is actually 200, and that seems weird. It still seems weird to me, even knowing why that happens, and basically, once you can understand why that is and it makes sense to you, then you're probably ready to learn Solidity. Best places to get started. The reference material, the first link there, is kind of the basis for most of this talk. But the Eris Industries docs are very, very good as sort of an architectural reference, not to be taken maybe too much to heart, but very much so good examples of how you might choose to organize Solidity code. And the Ethereum wiki goes much deeper into how the computer itself works, and so if you really want to understand the guts of it, you can go into there. And I'd like to sort of start by stressing in a big way that micro-optimizations are very important in code. And that's particularly the case here in terms of the environmental impact. And it's not something that many people are discussing or even really openly acknowledging, and I really think that needs to change, because you read things like this where the Bitcoin network's creating millions of tons of CO2 a year, and when you think about how many machines are involved in those computations and how heavy of a CPU operation hashing is, you start to realize that we're kind of burning a lot of energy doing this stuff. And it's also worth noting that in no way do future improvements and optimizations in the language make that statement any less true, because when you get down to the basic nature of things, energy is energy, and if things are inefficient, we're burning more energy than we need to be. And I suppose if anyone's ever, OpenSSL has a bit of a reputation. It used to run 80–90% of the internet or something, so I guess it's just as easily a question of how much carbon are we burning because of old shitty code in OpenSSL. And Ethereum 2, Proof of Stake, Peercoin, Litecoin, and even Ripple, despite its political shortcomings, are all great examples of where things should be moving in that regard. So in order to quantify efficient code, you need to sort of measure it. And for Ethereum, you've got the gas cost of your transactions, which is basically a measure of how much computation you're doing. So that's really good, that's baked in. And aside from that, you've got the storage that your contract code takes up and the storage that it needs to keep in memory in order to store all the data it's holding. So in terms of the relative importance of things, my suggestion would be basically to prioritize gas costs above all other things, because I think in terms of not just environment, but in terms of people's general nature, if you're going to have to pay more for something, you're not going to use it. And if someone's got code that sorts an array, a fraction of gas better than yours does, then there's a high likelihood that if that's churning away at tens of thousands or hundreds of thousands or billions of arrays one day, that yours is going to get swapped out and someone else's will replace it. So those are things to bear in mind. And it's also worth remembering that a blockchain is not always the answer, and they're very trendy at the moment, and everyone thinks, myself included, to some degree, that you can just throw stuff at a blockchain, it'll be awesome. And there are certain things that blockchains are great for and other things that they're not. And intensive computation is one of the things they're not great at. It's worth mentioning Truebit, which is an off-chain computation market which people are sort of playing with now, and the idea is that you can have a sea of actors who are all doing heavyweight computations and uploading verifications onto the blockchain, and it only really requires one honest actor to call out the people who aren't doing things right in that system for it to all be valid and verified and things. So that's pretty exciting. So let's just run through all the data types in the language to start with, because data types are how we describe the world in programs. It's how we measure things. So it's a very low-level language, so you've got all your typical integral kind of centered things, a lot of integers, booleans, byte arrays, and byte arrays are kind of how you'll end up doing a lot of things, because you just kind of chunk stuff into bytes when you want to pass it around a lot of the time. There's no floating point units, so floating point math is kind of too expensive and difficult for the EVM at the moment, so you're sort of limited to using fixed point, and they do, I think it's there, but the documentation's a bit unclear. Got my cursor on the wrong screen. The documentation is a bit unclear as to whether those are actually in there yet or not. I haven't tried playing with them. You've also got enums, and you've got all these nice little conveniences with the compiler, so you can actually write minutes, seconds, and things, and do the multiplication for you. So I reckon they're great things to use because it's very clear. And then you've also got constants, which are sort of an optimization, because once you start declaring contracts, all the variables you put in your contracts take up memory slots on the blockchain. It'll cost you a little bit of ether. So when you define constants, the compiler will just put that literal value in wherever you refer to it, and it doesn't cost you anything, which is nice. So those are value types. That's sort of the simple bits of data. When we get to reference types and start needing to describe complex objects, then we need to start thinking about where the data is stored. And with Solidity, there's just a keyword that does that, and all you need to do is tell it that this variable is storage or this variable is memory, and that defines whether it's temporary and it's just going to sort of stay there while it's computing the next block, or whether it's actually going to stay around and be stored. And so you can kind of think of it this way: all of your storage variables are in your contract, within the block, and then it comes up into memory, it plays around with it, that's kind of where it's thinking, and then when it's finished, it stores the next state of the block, and that's your storage variables. Also worth noting, there's no static stuff like you'd have in a normal object-oriented language, because there's no sort of class, because everything's just an object that's one contract that's been deployed. So you can do that stuff, but you need singletons, and you just kind of reference them as separate objects. Data location, so essentially it all follows when you just kind of keep thinking about things in terms of OO. So if it's an object that's stored persistently on the blockchain, then of course all of the storage variables, all of the instance variables in an object are all going to be permanent, and all of the variables passing through its functions are all just kind of transient things of its behavior, so they're just temporary. So that's pretty much the way that it all works, and that all kind of follows that way. Handling data location, there's quite a few caveats there. One is that you must declare storage in your function signatures if you want to operate on storage data directly, because if you don't do that, the default function signature is memory, so it ends up making a deep copy of all your storage data into memory, and you manipulate that and it doesn't actually change anything. So that's one to be aware of. And because of the way it all sort of works, when you deploy a contract, then the memory of that contract is created once. So when you delete things, really you're just setting it to 0 is basically how that works. And you'll see a lot of checks later where it's just saying, is this thing 0? And basically when you start doing references, you just need to remember that references are dumb, and the CPU doesn't care where the data it's modifying lies. So if you make a variable that references a piece of storage, then it's a storage variable. And if you make it reference a piece of memory, it's a memory variable. And when you sort of assign between different types is when you get that sort of conversion behavior. So there's more information at that URL. And I just sort of thought at this point it might be worth to stop and think about what's actually going on here, because the fact that there's no I/O and there's no separation between basically your client app saying I want to do something and then it just happening and being in the blockchain, in your database, in the permanent place in your app, is the terrifying reason that the DAO hack happened. Because in a traditional system, and this is an incredibly simplified, stripped back version of what a modern cloud website would look like, but you've got layers and layers of API gateways, and you have load balancers out here, and then you've got auto-scaling groups and application services and disks and all these things, and each of those is all generating logs of the things that are happening, and it's all managing little checks and balances to make sure nothing's going wrong. So when something does go wrong, you've got all this padding around here, and you've got all these log files, so you can usually, as the person who's built that system, work out what went wrong based on reconstructing log data and make sense of it again. But if you make a mistake here, you don't have any of that, and you just lose your data, and you're just sort of in danger town. So that's sort of the summary of the way that I/O works on the blockchain, and there being no I/O, and everything's close to the end result, so it's all super convenient, but with great power comes great responsibility, of course. So then you've got arrays, you've got nice sort of types for dealing with byte arrays and strings that will respect encoding. You can do fixed and dynamic arrays. They can be multi-dimensional, so you can make matrices and things like that. And C programmers need to be careful because the syntax is backwards to what I've been used to. So yeah, just something to be aware of. And there's a few little caveats. A little bit of extra storage space for dynamic arrays, so you can kind of pack values into smaller arrays if you want to write hyper-optimized things, which people probably will, but hopefully you just won't have to deal with that because you'll find someone who did it for you. That's my hope anyway. And then you've got other little things where if you make an array of mixed integer types, it'll make the type of the array the smallest or the biggest integer that will fit. You can't mix them, and you can't return dynamic arrays between external functions. So we'll get to external functions in a minute. And you've also got mappings, which are just for storage, which are a nice little convenience thing where you can do key value stores, and you've got structs where you can sort of create structures out of your simpler data types. And so all your standard stuff is in there. And then you've got addresses, and addresses are a bit weird because they are an integer, but they've also got this whole implicit API that goes around them. So in the contract you're in, you've got this, which refers to your current address. They've got this self-destruct method. They've got a balance. And they've also got all these other methods. So you've got sending for sending ether between contracts. You've got calling and delegating calls for sort of talking code-wise between contracts and calling functions on each other. You don't really tend to use call code anymore. It's a bit of an old one, so I'm just planning to ignore that. And none of them allow you to access the return value, which is worth noting, which means that you need the sort of interface file for a contract if you want to talk to it properly. And all of them return a boolean indicating whether the invoke function terminated or caused an exception. And that's basically because Ethereum has a very simple exception model where you can just say throw within your contract and it will abort everything that happened within your contract and roll it back to the contract or the action that called it. So yeah, essentially you basically can see if another contract's action failed or succeeded, but that's all you can see. And there's a bit of magic around that, so you can just sort of say this is an address, and then it's got a send method because it knows it's an address. And you can also use the value and gas methods of addresses in order to sort of, it's a bit like using bind in JavaScript. You can pre-populate or curry information onto functions of other contracts. So you can kind of go, I want to call it the info function of feed, but I want to actually send some ether with it, and I want to send a different amount of gas to normal to fund the transaction. And I kind of haven't really gone over that much, so if anyone's not aware, gas and ether are sort of, gas is the cost you pay to run transactions on the system, and ether is just the value of money. So those are all the things you can do with addresses. And then we come to control flow and syntax. Normal stuff, you would have seen it in any other procedural language basically. One thing is there's no automatic integer to Boolean, so if you're doing Boolean checks, you need to be checking if thing equals 0, if thing is not equal 0 sort of thing. And you can do sort of a limited form of tuples to unpack arguments from functions, so you can return 3 things at once and assign them on the other end, which is quite handy. But they're not real things, so you cannot try and do this kind of stuff because that will just throw up in you. And there's also named arguments, so you can mix arguments around and it gives you a bit of nice compiler-driven stuff to make that easy. Other weird things, order of expressions is undefined, it's function level scope, and exceptions are very limited and are just about avoiding a particular call to your contract. So then function modifiers, and this is sort of the first thing that's different about Solidity, and it's probably one of the more important things as far as I see it in terms of making your code good. So they're a bit like functions. You define them with a special keyword modifier, and then after that you can kind of just chain them onto other functions, and basically they run, and wherever there's an underscore in there, this function will get inserted in a way. So what it is actually giving you is kind of a limited form of functional composition where you can do this sort of thing. So this is achieving the same as this one here with an only owner check, but I've pulled it out into an only by sort of base one where we can sort of separate the data it's based on, which is the owner, from the modifier itself. And when you start to really pull them apart into pure little modifiers like that, then you can very cleanly chain on behavior and properties to functions in ways that don't add new logic and don't introduce new bugs and new conditionals. So that's quite a nice little convenience. So yeah, my recommendation would be to write them as pure functions as you can, and then just build them up slowly, because it will give you a much broader palette to play with. And there's a link there, condition-oriented programming, which Gavin would put out after the DAO hack to talk about this kind of technique. And in terms of the contract structure, it's all basically what you're used to in C++ or Python or anything else with multiple inheritance. And I say that shaking a little bit because multiple inheritance, we all know, is kind of a bit of a code smell when you overuse it. So that'll be interesting, but fingers crossed we're all going to end up using nice shallow inheritance graphs without too much cross-dependency. And I just sort of thought maybe a nice convention to do would be, if you're not planning, if that's an abstract class, give it a lowercase letter, and then if it's not abstract, maybe give it an uppercase, because I've seen a lot of code where it's a bit ambiguous as to what you're actually wanting to deploy to the blockchain. So, and there's also a bit of an extension to usual Javadoc stuff. They've added these notice ones and dev ones, and the notices are quite important because that will actually show up in the wallet when you're interacting with a contract directly, so you can give people hints as to what's about to happen, and you can even do these little parameterized expressions that it'll evaluate in JavaScript and show them previews, so that you can tell them how much money they're about to send, and all kinds of little insights into what they're about to do. Excuse me. So, and you can also write inline assembly if you really want to go right in there and get super dirty and do a lot of low-level hacking. So I'm not entirely sure even what an end-load operation is. I've never been inclined to write assembly, but suffice it to say, when you're looping over an array and doing this, every time you loop, the compiler has to check the length of the array to work out if this is out of bounds, and when you're doing it this way, it doesn't. So little optimizations like that can get you a long way too, and you'll probably see a lot of code coming out like that from very smart people that you'll just be able to use. So contracts calling contracts, the scary part and the fun part. So we have to talk about method visibility to understand this, because basically in Ethereum there's two types of function call. It's either going to be external and it's going to be going between two contracts, or it's going to be internal and going just within its own contract or within methods it's inherited from its parent class. And because all contracts use concatenative inheritance model, it means that basically all your superclass logic is identical to your base class logic. There's no kind of delegates or lookups going on. It's all just copied into your class. So, and it's important to note that the use of private and public there, it's not actually private in terms of no one can see it, because it's a public blockchain. It's still there. It's just not exposed to the outside world. And if you're a elite hacker who likes looking at ones and zeros, I'm sure you can find it out. So there's, between those external calls, there's actually a lower level API between contracts, which is happens down at a lower level in the CPU. And it's an interface that only provides data types that are common across all of the languages that you might implement. So in those external calls, Solidity code can talk to Serpent code can talk to LLL code, it doesn't matter. And that's why you have that reduced set of information you can deal with there. So basically, it seems like you're going to want to end up encoding everything as byte arrays at those boundaries and decoding it on the other end, and there's probably going to be libraries to assist with that at some point soon. Oh, and the caveat there is that when you're using the this pointer within your contract, you are actually making an external method call back out and into your own contract, so it behaves differently to calling the methods privately. And internal function call is very cheap. It's kind of almost like a go-to statement in the way it's compiled. External function calls happen as actual functions with stack allocations, and so the EVM limits that to 1024 to stop people doing re-entrant recursive hacks, and that's the reason the DAO isn't completely empty right now, so that's pretty handy. And as we've already mentioned, since they happen to that low level, you have to deal in those low level types, and it actually copies them by value between contracts, so it's like each of your contracts can't directly manipulate the data within each other. You can only kind of give them back one so they can update their own data. So the summary is basically simple data types between contract and encode and decode yourself. There are such things as header files and ABI description files, which provide interfaces to contracts that have already been deployed, and that is how you set up integrations with contracts that you didn't develop in order to behave the same as the ones that you're using natively in your project. That was really hard information to find, and I kind of came across it indirectly digging through the consensus standard lib repository, so I haven't played with those yet, and it sort of seems like something that they haven't put a lot of tooling around so far. So, fallback functions. And earlier we talked about send and call as ways of sending value between contracts. And so this fallback function is what actually gets run when you do that. And it applies to send as well as when you call without giving call anything to tell it what method to run. And basically, most of the time, if you're building a contract that you don't want to hold money, you put in a method like this, which just says to throw, and that'll tell it to just, okay, you tried to send me money, no, I'm not going to accept it, and then you get your money back, so that's really easy. And when you send money to a contract without this function, it's essentially an empty function, so that's why if you just send your money to a contract that doesn't implement this, you lose your money, because it just kind of gets swallowed. So you can kind of think of address as being part of the prototype chain of every contract, and it's really a superclass in the sense of classical OO as well. And there's that implicit fallback function of just the empty function. So when you know what's contained within the contract, you can just typecast it, and then you can deal with it in terms of your own API. So because we know it's a test, we can just typecast and then we can call A. Though I think that might actually should say test. Apologies. So how do we check the type? You can't check the type, which is a bit lame, but what you can do is create registries where you've sort of, in a permissioned way, when you set it all up, assigned addresses of contracts that you know are legitimate contracts, and then you can just look those up with this kind of technique, which is really a lot like a term of dependency injection, where you've just got a big registry that you're naming all your things, and that's a pretty important part of architecture that the ARIS tutorials go through a lot. Because what you want is the ability to swap out contracts and upgrade them after you've decided you want to change things, and that kind of indirection is how you do it. And you can also create new contracts with other contracts, so we can create a new B within an A, and we can also provide them value when we do it, so in the same way that we use value and gas for normal contracts, we can do it when we create them as well, and create things with money in them already. So then you've got library code, which is pretty damn cool. And the way it works is that delegate call method, which means that essentially you grab the library contract and you run its methods using your own contract as the context of the function. So it's kind of like using apply or call, just call in JavaScript. Same. Anyway. And the important thing with that is using the storage keyword in libraries, because you get the state of the contract that you're being called on. So if you want to run a library to manipulate some data in a particular way, you can do that. So this is a sort of a simple example of a set, and it's just a set of values. You can insert some, you can remove them, and you can check whether it's in the set. And you've got some storage data that you can pass in. You're just going to call it self, and I've highlighted it red because that seemed like a nice convention to follow for me. And you can set a value. It's just an integer. So that's about the API, and that's how you would use it. So you can import the set, you can access its members, and you can use its methods. And it might look like you'd sort of read that as a static method call if you were used to C or Java, but in actual fact, what's happening there is set is running sort of insert with contract as the member, and then because known values is a member of contract, that's how it knows to look it up. So it looks normal, but it's actually a little bit weird. And because of that, you get some interesting things. So you can import the set and using this using syntax, and then once you've done that, what you're basically doing is taking all the methods in set and applying them to set.data. And once you've done that, then you get the set's methods on set.data, and the variable itself gets passed in as the first parameter. So it's kind of like you get this nice little way of automatically currying this first parameter using the using syntax. Yeah, and you can also do that for built-in types, which sounds like not the best idea to me, but I take the point that potentially this is a way that they're going to extend the language further later. So maybe they're going to want, you know, more functionality in arrays later on, and they can build that into the language, but they can also, if you're running an older version of Solidity, you can just import a library and use it. So it's quite possible that this is how we'll end up extending things later. And so, okay, events. And events are ways of sending out data from the blockchain without actually storing it in the blockchain. And this example here is the reason why you might want to do that. So if you had a bank and people could make transactions in and out of the bank, and you just want to store their balance. You don't care about when they took money in and out kind of thing. You don't need to store that, but it would be nice if people watching the website where they're looking at the bank could see when money was going in and out. So in order to do that, we can use events, and really the events is a way into the blockchain logs, and the only real difference between them and blockchain data is they don't stick around very long. So it's the last 256 blocks that you get to see that for. So very good for sort of transient data. And something in the docs pointed out that there's a bit of a dichotomy where you need an event in order to get data out into your dApps in the JavaScript layer, but you also need a return value in order to get the data back from other contracts within the blockchain. So you kind of need those two paths to get data out. And once you've sort of hooked them all up, it's really just a case of saying that you don't need to make things indexed, but you can, and when you've made them indexed, you can apply these filtering criteria in your JavaScript in order to bind to them, and lets you filter events and trigger things based on those values you're passing through, which is how you can make real-time apps on the blockchain. So that's all the bits and pieces, and that's a lot of information. How are we all doing? All right, cool.
That's
cool.
pretty amazing.
Good. All right.
You powered through it.
All right, good.
I think it's just you're throwing us in the deep end, and it's good to just have it all at us. Yeah.
Excellent. So, how do we make it run well and not be bug-ridden? Let's run through a few things that I was wondering about the best way to do when I was looking through the docs. So, do we iterate or do we recurse? And the answer is basically, if you're running internal functions, it doesn't really matter. They're cheap as, do them if you want. If you're running external functions, you'll hit that 1024 stack depth limit, so don't do it so much if you're going about things with libraries in particular, because they are external function calls. Mapping versus array. Mapping can only be used for storage, so if it's an in-memory thing, you don't want a mapping, and unless you need to iterate, you don't need an array, because mappings don't have a length value, so there's no storage spot wasted for that, basically. Composition or inheritance. It doesn't really matter that much in terms of speed, but either technique will lead to larger compiled contract code because it's concatenative. So if you've got a big base class with 50 methods in it and you're only using 4 of them, that's a sign that you might want to split that class up, because then you've got 46 methods in there you don't need. And I've sort of noticed that inheritance leads to name collisions, because essentially the way it works, it's a bit like a mix-in JavaScript. So we're just kind of slamming more properties into our contracts each time we inherit. And it actually seems to silently just ignore that and overwrite them, and I can't tell which of my parent variables it's actually assigning to. So that is a worry for the future, I think, in terms of a standard library and well-organized code. And it does seem like it's the kind of thing that might cause bugs, so question marks there. And just a quick mention on delegates, because the stuff that libraries do for you, delegate call lets you do manually. So if you've got other contracts on the blockchain that aren't libraries that you decide you want to use as libraries, you can still do that. And you can do it with that method. So then we've got a few opinions on design patterns that are worth a read if you want to go through these in your own time. A big question is, do you actually really want to make your contract self-destruct? And it seems like a good thing to do as a good blockchain citizen, but you have to remember it's not actually going to be saving you any space, because if you stop using the contract, it's not going to be written to the next block again. It's just going to sit there in the state it was, and if you delete it, it's going to get deleted but still sit there in the state it was. So deactivation maybe is more useful sometimes. And you can't redeploy to the same address, so this is where the lookup contracts come in, and you can actually just kind of call with message data. Message being one of the automatic variables that comes in with every transaction. So There's a 5 types model of ERS Industries guys talk about, which I thought was quite a nice way of thinking about it. And the big thing which they everyone talks about is separation of concerns. So it's a good idea to keep your storage contracts just doing storage and being really dumb, because if you put your business logic in there, that's the thing that's going to change, that's the thing that's going to lead to complexity, and then you'll have to find some way of migrating your data out of your contract, which would be probably really nightmarish, I imagine. And then management contracts are the things that sort of enable that. So you've got name registries and proxies and ones that exist to sort of join the dots between them all. And you've also got application logic contracts. So the way they talk about it is that you would use these higher level controllers around your kind of core controllers, it's a bit like microservice design in web architecture, I suppose, because you're building it up as an API gateway that people talk to. And utility contracts, because there's always something you can't organize in every project. And they also talk a little bit about action-driven architecture, which is essentially the idea that this layer should all be oriented around actions, so that you're dealing with behaviors in a system, and if the behavior slightly changes, it's easy to swap it out without interfering with other bits of behavior in other state. And here's some weird gotchas in the language. Always call local methods because of the whole this will be an external method call thing. Don't use now or block hash as a source of randomness, because every single computer has those values. And now is time the last block happened, not the exact time of now. The constructor doesn't stick around. It's only used to initialize the contract, so that's an interesting one. And that for loop one is probably the craziest thing that scared me most, because that loop will just be unbounded and loop infinitely, because here the compiler goes, you haven't told me what kind of variable I want. I0, that's a char, so I'm going to make that a 256-bit number, and if this array has more than 256 elements, then it's never going to get I greater than that array length, so it'll just keep looping. So, and that's the kind of thing that obviously you wouldn't find out until years after you deployed your contract and you had a few more people in. So yeah. So, the DAO hack, what went wrong? And I feel like I could say this because I bought a t-shirt, I lost my money too, so we're all in it together. And yeah, spot the bug, which is of course a rhetorical question, because the bug is probably the least obvious thing you could imagine. And here's what happened. So we have this method in the DAO called splitting, which is where the DAO, if you disagree with policies that are being made, you can vote to split off from it and form your own DAO, and anyone who agrees with you can join you, and those who don't stay behind. So what we have here is the attacker starts by sending extra gas to make the computation longer than the DAO intended into split DAO, because they didn't guard against that, which then asks it to withdraw their money and pay them out. And paying them out means checking their balance, and okay, that's their balance, I'll send it back to them, and it uses call.value to do that. So split DAO is public, so the attacker has a contract with the fallback function they've made, and when call value comes in, it just calls split DAO again. So then split DAO calls withdraw forward, calls payout, checks the attacker, sends another one back, and now they've been refunded twice in the same call. And they keep doing that for a while, not for as long as they want, because if it ran to the bottom of the call stack, we hit the 1024 limit and Ethereum would go, call stack exceeded, and roll back the entire transaction. So they're careful not to do that, and I think, does anyone know how many drains they got per run? It's like 8 or 10 or something like that, not
sure.
too many. So they keep doing that, and eventually they all start, all the functions have been allocated, it's all run, then they all return their values back up to the parent function. And on the way back out, split DAO is supposed to call transfer to kind of finalize the balances and move the attacker's money back out into the reserve spot. And that would all be great, except that it doesn't do that, because there's this transfer function and there's also a transfer event, and the only thing differentiating them is the casing, and events don't do anything except send an event out to the blockchain. So, whoops. And so when that happens, the attacker within the return after split DAO comes back can just kind of ask the DAO to transfer their money to some other contract they've made, and so they move their tokens into this other contract. And DAO finishes and says, hey, their balance all checks out, this is all great, everything worked fine, and then they can just ask it to transfer their money back to the attacker, and they can do the whole thing all over again. So that's how they did it, which is a pretty strange and contrived and curly set of problems.
Can we?
So
Can I pause that?
yeah.
Talk there for? Can I stand up there with you and just, a lot of people are very confused about how this really happened.
Yep.
And I ask you questions, and we
Yeah,
just
go
go
for it.
through and run through it again slowly.
Yeah.
And we'll just And I'll just make sure we get that. And we'll just break it down in simple English for people. All right. So the first step, go for it.
So the first step
We had a contract.
we have a contract that the attacker's made.
And they send a call to say split the DAO. Okay, and then we want to withdraw some funds and go to a payout. And then what happens here at this part?
So within the payout reads the balance that they have within the DAO, the balance of ether they have left.
Of the main DAO?
Of the attacker's balance within the main DAO.
Oh, okay. So it's choosing, it's reading what the attacker's balance, that contract's balance is, and it puts it in here. Let's say, for instance, it's 100.
Let's say it's 100. Yeah.
Let's say
it reads
it's
it out,
100.
so it's going to try and send 100 ether back.
So it's sending 100 ether back, and then the next slide is.
The next slide is the attacker has their fallback function within their contract, which gets called when the ether gets sent back.
So the fallback function is, again, explain what that is.
That's the method that you define on the contract, which when you just send the contract money or an empty function without asking which function
it's a default
to call,
function, isn't it?
It's a default function.
Yeah. Okay. And
so you didn't tell me what to do. I'll do this.
I'll do this. So it's default function. And so it does the same thing again, basically.
Yeah. So
and it keeps doing it. So it keeps hitting the master DAO contract with the same function.
And so
again, sending through a balance that it wants.
If we go back to here, we can see that it does the withdrawal for, but it's not until after it withdraws that it sets their balance to 0. So while we're still withdrawing, the balance is still saying that it's 100, and it still hasn't been decremented.
But then there's another call going through.
So they can just keep running and keep running this function basically before this ever gets called.
And that's because of the delayed block time, basically.
No, actually, it's just a circular function call that just keeps going, and they haven't updated the state within the DAO before all this finishes.
Yeah, okay. So it does it multiple times. Do you know how many times it does it? You don't know.
I'm not quite sure. Yeah, it wasn't too many. It might have been on the order of a dozen or so.
Yeah.
Because they can't go below that 1024 limit, and they also can only specify a particular amount of gas, and that's how much they need to fund the recursion.
Yeah, so they max out on how much gas that they can do to do this maximum amount of times.
Yep.
Before then, because it stopped and then it started again. I remember watching it go down.
Yeah, and I guess they were probably tweaking the amounts to work out where the sweet spot was or something like that.
And that is pretty much it. There's nothing else more to it.
Pretty much, yeah. Except that on the way out, he just needs to move it between funds, and then when the DAO runs its little internal to check to say, did I withdraw them correctly? It can check, and it sees that the balance has been emptied out because he did it his own way.
Yeah.
So it's like it's fine, and then it keeps going. But in actual fact, it's been had.
Yeah. Anyone have any questions on that? That's the most detailed explanation of it, actually, how it really happened that I've come across, and I've been researching for ages.
Dug in that a bit. It's a bit of a mind bender.
It is a mind blender, but I have a question about that.
So why is it designed so that the attacker can call back into the DAO, the split function again?
That's just the way it goes, because the attacker can do whatever they want within that fallback function. They can grab any address, call any method, call any contract. So
is that because they coded it to be public, or is that just an integral part of being on the blockchain? Is that no matter what you create, it's going to have to be public?
No, they coded that method to be public, but they needed to because that method's the one that starts the whole split sort of thing. So it's actually the method that you needed to run is the method that you needed to run again. So there's no way they could have stopped you running that method kind of thing.
So the interesting thing is that you can put any fallback function into the actual contract that's sending the attack, basically, or into. That's weird, I find, isn't it?
Yeah. So the upshot of it all is basically that you have no state guarantees outside of the contracts in your project, and you have no state guarantees once you interact with any outside contracts. So I guess the thing. No remedy.
Is that what you're saying?
In a way, yeah. And I guess the thing is that when typically you'd be used to doing it the other way around, right? Like I'm used to, if you're going to do a transaction with another system, you do the transaction, and then if it fails, then you change your state to say it failed. But in this case, you need to do it the other way around because the other person might be doing whatever the hell they want, kind of thing. And if you haven't set a value to stop it happening again, it's quite likely they can make it happen again.
Gotcha.
So these are the guidelines, and I guess they're all really guidelines about guarding against race conditions and mutable state. And
but if you set a block on it, if they come up with something more advanced again, they can continue to move the target, can't they, essentially? So.
No, it depends on an order of execution.
Yeah, no,
so as long as the order is happening in the right order, then you're okay. But it's a really difficult, fine thing, right, to know which order things happen in sometimes. So that's the first point, is if you update your own contract state before you interact with the outside world.
Gotcha.
And if the interactions fail, handle the effect in a way which doesn't interfere with any other address being processed. And that's also quite a difficult problem sometimes, because say the DAO is splitting and it's got a mapping of or an array of all the users who have bought into it, and it needs to refund them all. You need to make sure that if any of those fail, it doesn't cause them all to fail, because then no one gets the money back, or everyone gets too much money back, or something horrible happens. So and it's really a consequence of the fact that we're writing a language to directly mutate a giant piece of state. That's what the blockchain is. It's just a big ledger. So if you've got code that's going to be mutating state, another code mutating it, then all bets are kind of off very quickly. So it's a little bit sad for me, because I see it as a big sort of vision of this can be a computing fabric where everything just happens all across the internet. But I realise it's going to have to maybe be a bit more sandbox than that, because you're either going to need a cryptographic hash to prove that that address has the right code on it, or you're going to have to be rolling all the source code into every contract you create yourself because you don't trust anyone else. So it's interesting.
What do you see as the solutions to big, just giant sandboxes? I was suggesting that we have multiple levels of testnets, basically, and testnets that use real ether, basically, but and they stay in there for 12 months before they get released into the wild.
There are things. There are things that people are doing. I've got some in a few slides.
Yep.
Anything else on DAO?
I just have one more question. So once we were in that state where the contractors loop through and call a few times, and then it stops calling, and we get down to say after the payout line.
Down to here somewhere.
So we get
this is the
down
payout
to
line.
Payout. So once we get down to the line after that, paid out underscore account, is there anything that if we throw an exception here, is it going to cancel that whole series of events, or has the ether already been transferred?
As in, if we throw here, are we cancelling this transaction here?
Would it cancel all those transactions, or would it just?
I think it would. Yeah.
That they will all sort of execute as a block.
I think that's the way it works. I think it's essentially stack is going down, and if you throw, it's winding back stack, just like if you were throwing an exception sort of thing. So I think in that case, because that's all within that function, you'd be winding back all the way up to that entry point, or to split DAO that called it, presumably.
So it would have been possible for them to put in some logic after that sort of, because you said that they did have some logic that then did a further check.
Yeah, which is this transfer method, I think. So that one there is actually calling event transfer, and it should be calling function transfer. But that's the one that actually shifts the DAO tokens internally within the contract.
Yeah,
I think. So that one's about once it's split off, it has to transfer the tokens out of its DAO into the new child one. I think something like that. So if this had been above withdrawal reward 4, then we would have been okay. I think, yeah. So that's the subtlety of it.
Lesson learned.
So there's these are the kind of articles that came up that I ended up going through, and then there's this list here which has all of these and quite a lot more that consensus was collating. So we've talked about update your own state first, and dealing with failures, and basically presuming any methods might just be called by things that you don't expect, presume that any externally accessible methods might run out of gas and fail, and presume that any externally, that never presume that an address implies a user, because sometimes users can run code when you do stuff to them. And using send instead of call is safer because send is basically an alias for call with value 0. So
they also could have avoided it just by using send instead of call.
Yeah, because then there would have been no extra gas to keep recursing, and I think it's 2300 gas is just enough to send one event or something like that as the default. So yeah,
it's amazing that one line of code would have been the difference from
between $35 million.
$150 million.
Yeah,
$50 million. That's insane.
It's insane, isn't it?
Yeah.
So I kind of like to think of it this way. Imagine if you're running a threaded language that just there's random threads accessing the memory all the time. That's kind of what it's like. So yeah, it's interesting. And I'm thinking maybe we need a better convention than an uppercase thing to distinguish an event and a function. So that would be, and I know that's got a name, that style, but the whole type prefix. But that's what I was thinking. And I just thought it was kind of worth mentioning the whole cattle versus pets metaphor that Bill Baker, Microsoft, came up with, and yeah, I think this new wave of computing. We're talking about computers as wildlife now, so you know, everything's running of its own volition. You can't trust any of them to do anything, but you can kind of look at the whole system and it all works beautifully and seamlessly. So that's Web3 in a nutshell, I think. A few more suggestions. Unit tests, do lots of those. Keep dependencies lean. Use function modifiers as much as you can, and learn about functional coding if you've been an imperative coder your whole life, because it will cure cancer. Other vulnerabilities. This was an article I read that just kind of made me giggle, because it's like, so if we think about the DAO as this kind of problem where you've got a function that calls a function that can just keep calling the function over and over, they're saying that this is another critical horror bug in Ethereum, where you can have a function that calls a function that calls another function that shares some state with the previous function. And it's like, yeah, cool, but that's how you write code. So that's software, and you know, that's where bugs come from, and that's why everything's terrible sometimes in software. So really the 3 points are the big things to remember here. A logic error in a software program doesn't mean the language is broken. A vulnerability in a language doesn't mean the CPU is broken, and a language which allows sloppy code doesn't need to be doomed if you can build good tooling around it, because I know this, I'm a JavaScript developer. Towards a better language, maybe. If we're moving towards pure functional languages, rich type systems, I mean, Solidity's got a pretty rich type system as it is, but really we're looking at wanting things like formal proofs and mathematically derivable languages, and ways where you can empirically prove that this thing is going to behave in the way that you want. Cinero are a social network that are their own blockchain. They operate on a sort of reputation, article quality basis. They have a language called Rho, which they've been using internally, which does some of these things. And Tezos, or Tezos, or however it's meant to be pronounced, is one that I kind of came across last night, which is written in OCaml, and looks like it has all this stuff in it. Even he's planning on making a proof of stake thing at launch, so that's one to keep an eye on. And just kind of some things I've noticed. They're a bit like mix-ins. Is that great? I'm not sure. I don't think so. Variable shadowing, I've never used a language except for PHP that did variable shadowing in a way that didn't lead to bugs. And yeah, having this whole account object that's just a number is a bit hectic when you're being really strict about typecasting. And I'm not quite sure about paradigms, but yeah, I think small is good, and we are maybe looking at people doing big, cumbersome things because of the way they see it being structured. Not sure. Solidity 2.0 looks very hopeful. We've got template types coming by the look of some code I've seen. We've got pre and post conditions from the NatSpec being enforced, so that you can be sure that things are going to be expected when your functions run. And this was one I saw in some of the older documentation, which looks like they're planning on doing these kind of contract invariants, which would I presume be kind of compiler enforced assertions that run at the end of transactions, where you can make sure that things don't go wrong, which would be a really good thing to have after the events of the last few weeks. And there's this dynamic keyword that might be coming in, and that sounds interesting because it sort of implies that the language is going to come a lot more freeform. So I don't know if that'll be good or bad, but I'm interested to see. In the meantime, Solidity, someone's making a linter, so that'll be excellent because there were all these little things about casing and conventions that I'm talking about. Maybe we'll have some formalization of. This tool will generate you .call graphs for your functions, which Visual Studio Code plays with really nicely, and that helps to let you see what's going on. And Oyente was one I found, which is sort of still being written. It's a Python thing, which does like that whole vector solving thing on the call graph to try and work out, and basically it'll programmatically detect if some of these vulnerabilities we've been talking about exist, so you can run your contract through an analyzer and see if it's vulnerable to the same kinds of attacks. Unit testing frameworks, I thought it was interesting. I tried looking for some, and a lot of them were ones that I would consider as integration testing frameworks because there's lots of different ways you can test a blockchain code. You can test it at the DApp layer and see if you send in stuff and what comes out. You can test it on the contracts. You can run those properly on a VM. You can run them in a series of, all kinds of stuff. So these were some of the ones I found. We've got this one that just runs a JavaScript interface and lets you script transactions and test them. These two sort of works in progress. This one supersedes this one. Yeah, they both work on sort of running it in the JavaScript virtual machine, but it's still doing in-language tests. And I came across DApple, which definitely looks interesting because it's an entire development suite. It's kind of looks like the CLI-driven toolchain that we've been looking for this sort of stuff, similar to NPM, so that we don't have to use Mix and big kind of IDEs to do it, which are a bit premature anyway in terms of their interface. Yeah, it's got NatSpet debugging with this sort of, so you can put in these comments and they will actually print out to your log while the app's running, and gives you an interface to IPFS so you can store data, and it looks pretty cool. And then I found some code, so this is just a bit of a list of some of the stuff that's around. It looks like some of the founders are working on standard libraries. They haven't done a lot yet, because I think people are still all quite unsure as to how they want to use things. But I've included this script in the repository that this talks in, and you can run it and clone all that stuff. And yeah, there's a lot of good things in there. So you've got name registries, config databases. This was kind of a bunch of interesting standard libraries. Oops, where are we? Yeah, these guys looked like they were building something quite real world, following a lot of the Eris patterns, and some useful little modifiers and things there, and some data types. So yeah, early days, but people are playing with things, and those are quite interesting to look at just to see how people are building stuff. And just to mention, there's a few on-chain services for things that Ethereum can't do. So the alarm clock will let you schedule tasks in your contracts, and they can run at intervals and whenever you want them to. The RAIN DAO generates random numbers because you can't generate random numbers inside the EVM. And oracleize.in is actually, maybe not on-chain so much, but it's a gateway service that lets you authenticate Web2 providers, Facebook, Google, Gmail, all those things, same thing, into the blockchain. So yeah, starting to connect the old world with the new world. And just a few final observations. The risks are high, and blockchain languages are about direct state manipulation, and state is evil, so it's scary times ahead. Errors happen due to orders in state manipulation ordering errors. There's no state guarantees when you're interacting with external contracts. We need better code analysis tools. We need better code writing tools, and maybe we even need better languages. But we'll see what Solidity 2 brings, I suppose. So yeah, the end. That's my rant. Any questions? Yes.
Where did you get your shit?
Twitter. I don't know. It just came across, and I was like, yeah, I'm gonna be looking like that. Why not? So yeah, now it's definite. I bought the T-shirt.
Yeah.
excellent work, and thanks on behalf of Meetup and the internet for publishing that stuff. I'm sure that we're not the only ones who find that really useful.
Yeah, hopefully it gives some people a bit of a head start.
I feel like I need to go through it about half the speed that you went through it on.
Yeah.
But
There's definitely more than an hour's odd stuff in there. But yeah, all these links work, and so that's pretty easy.
Yeah.
Right, so you've got it
He'll put the slides up as well. And
the
put
slides are up,
to,
so
towards it as well.
you can grab them there or there, basically.
Yeah, so that's all.
And they're all online.
Boom, boom.
Any other questions? Does anyone want to ask anything?
We all got to have a bit of a crack at it, eh?
Yeah, it's time now, I guess. Yeah, that was what Paul was going to be doing, but next time maybe.
I got another question. What's your opinion on the hard fork versus non-hard fork situation?
Yeah, I was having a debate with someone on IRC about this, as you do.
Yeah,
as you do. Yeah. I guess it's his point. His gripe about it was, if we have a hard fork, then aren't we undermining the whole thing? Because and he's kind of right. It sort of serves us right, really. In my opinion, but the point of the technology was to enable consensus, and if we need to go outside that in order to agree, then does it really matter? We're still achieving that goal. So, yeah, I don't know if I have a strong opinion about it one way or the other. I'm quite happy to lose the money, as I think as a point in history of this dumb thing happened. Let's remember it. But yeah, if we're going to wind it back, then I guess why not?
Yeah.
It'll save people losing some of their money.
We'll see what happens.
Yeah, I mean the fact that yeah, that's right, and it was always, this is the riskiest investment you could possibly take, so it was a risky investment, you lost money.
The interesting thing about the DAOs, can you sell DAO tokens on the exchanges?
I haven't. You can on some of them. I haven't tried it, but some of them do integrate.
Because
yeah.
I mean the DAOs, the valuation of it is actually quite close to what it was to start with it.
Yeah, I noticed that, and really the price of Ethereum hasn't changed as much as I would have expected either. It's sort of gone down slowly, but not more so than it has been.
My understanding of it is that, even if the tokens get destroyed, the ones that have been stolen, and ADL gets burnt, isn't the DAO tokens just a representation of the pie of the DAO?
Yeah.
So it could be just reissued the tokens.
Yeah,
that could be just
absolutely.
something that we send to the contract, and that's it, and then problem solved. That's my understanding of it, but
I think
say that's wrong. I actually think that.
I did think that at one point. I agree with it.
Yeah.
Was that what they were trying to do with the soft fork? And then,
that is it, yeah,
and then they found out that was another attack vector
there's
somehow.
some more vulnerabilities in the soft fork.
That's
Yeah.
the crazy part, yeah.
So now everyone's postponed on that, but
what's your opinion on the? Isn't it, from my understanding, 2 more days, and then the first sort of that things can be.
They can actually move the money out of their split.
Yeah.
Isn't it said till it gets too messy to continue? You can still do it, but then it'll start getting really messy.
Well, that's it. I mean, yeah, in theory, it just makes the problem all that much worse and more difficult to come up with a solution.
It was June 14th, but then there's another 2 weeks before you can actually get it out.
So what's the question?
Oh, I was just wondering, do you? And I would ask anyone here, because I'm sure we've all been following it super closely. We're 2 days out from sort of a point where more damage could potentially be done, and I just wanted to see, get an overall feeling of, do we think that a consensus can be reached by those 2 days, or what, are we feeling optimistic, or are we more hesitant? That's what I was just wanting to ask.
Softfork consensus was in 5 hours, wasn't it? That's how quick it got there, but this is a bit more serious. I think it'd take a bit longer.
Than the
and
2 days?
They gave it enough blocks that it was 6 days or something.
Yeah, sure. Yeah.
So yeah, I don't think 2 days is enough time, but I don't think they have that in mind if we've got to this point.
Who will make the decision? There's 2 days to go. is there some controlling body? Pardon my ignorance, but is it just going to roll through for 2 hours, 2 days while everyone talks about it? Is anyone in control of having consensus, or what happens?
No, I don't think. I think it's all just communities, people in forums and chat rooms bickering, really.
But I think, what you're saying is how is it executed?
Yeah, so there's 2 days to go.
Yeah, so what happens is there's some programs will upload some code onto GitHub, and then the miners who provide the processing power on their computers, they can choose whether or not to implement that code or not. And if 51% of those miners starts running that new code, then it will execute this contract to hold the funds, do a soft fork basically.
Right, okay.
And so the whole blockchain starts going in this new direction, which did happen to Bitcoin in the early days, and so it might happen to this. Did anyone invest in the DAO?
Yeah.
You invested.
I did. Yeah.
Anyone else?
By the way, Ivan was talking. He has to invest in
He put a fair bit.
He did.
I can't say, but
yeah, well, I mean,
I put $50
so he feels
in. I
fairly
wanted to go
passionately
through the
about
process.
that.
Yeah.
I bought some tokens at a big discount on the exchanges, so I've already got some of them back at a higher price. So I'm pretty happy.
I bought them when people don't.
Yeah.
Thank you.
So that way you were saying thanks to the DAO.
So just dumped in my buy orders again. That's all.
Does anyone follow the Ether Review, the podcast by Arthur Forbes? Beautiful podcasting, but the latest one on there, I'll share it in the meetup, but there's a guy called Vinny Gupta. I think he's I don't know what his position is, it keeps changing, but I know at one point his position was that he's in charge of ensuring that the Ethereum Foundation has continued finances through the Ethereum central banking model, which works really well. But I just think what he said is beautiful on that podcast is basically forget about the DAO, forget about this whole fintech industry, and let's move on with what blockchain can really achieve, and that Ethereum needs a whole new vision. And he's suggesting on this podcast that, and this might sound really crazy, but it was a shock to me when he said it, but basically, this group of open source programmers, should really team up with a giant body, the biggest body on the planet, which is the United Nations, about solving things that are much bigger, like the carbon crisis, global warming and things like that, and let's see a real proven solution to all this. And then we're not going to be because the risk with the whole DAO at the moment is that we're going to be regulated by some regulatory body, and it might kill off a lot of blockchain innovation. But yeah, what's your thoughts on that, guys? I just sort of think that's just a great idea. We're all in this boat together in the end. That's what I find.
You'd have to think long and hard about the body that did that, because there's a lot of people that have serious questions about the reality of what the World Banks and even the IMF. The IMF is one, but who did you say?
The United Nations.
The United Nations. So there's a lot of people there's a lot of evil going on in there.
Yeah, but they can't. Ethereum's always going to stay open source. The core of it, so they're not.
But if you're talking about something regulated, well then.
Just but by them, what Vinny suggests on this podcast, and I have a lot of respect for him. He's a really weird guy.
He's the original stone.
Yeah.
He's the guy that basically stood up there and said, somebody from the future's come back to us and given us this gift.
Yeah.
Now we have the opportunity to really make something different here.
Yeah.
And I think that's why he still is holding that whole, because we get frustrated by the whole fintech dominating these conversations, because it's all about clearing houses and about trying to save their own backs, because they know that if they don't, we will actually, people do make different decisions. So I think, we've been given a gift. It doesn't work. It's all clunky. We know that. It's not perfect. But it's given us different ways of imagining solving problems.
Just needs more work and more development.
It just needs more. We just need to be a bit kinder to it and just chill out and just break the thing, but just see what it can do.
Well, his suggestion was that the reason why to partner with these larger bodies is that they would inject, hundreds and hundreds of millions of dollars, and just get, millions, maybe 1 million people thinking about this stuff.
The question is what kind of
And
strings
paid full
come
time.
attached to those dollars?
Yeah, that's right. That's the problem.
Mm.
What comes with the dollars is always, you know,
What people
commitment to
have
that.
control, yeah.
Yeah, that's right. So that's a tough thing. I think that the plight of people, there must be a relatively short amount of people who put quite a lot of money in this already. There's people that have put a lot of money in, and people that, but I gauged by the discussion that we had last night, that the passion that Ivan was talking about was there's a lot of his dollars that are about to go down the drain. And, and there are, we, as you said, we made a mistake here, and this is development, and we're in a risky business, and things are going to happen like this anyway. But then you get down to the raw core of it is that someone has committed, an act of.
Yeah, just because you could, it doesn't mean you should have.
No.
That's what, just because you could doesn't mean you should.
No, of course not. But I mean, then is there going to be a situation where people, next week someone's allowed to actually
But
start
I guess the
steal all
thing
this money?
is that you can look back in the entire banking, banks are getting corrupt. It's everywhere. It's
Oh,
just
they are.
Yeah,
They
I
are
mean, we
everywhere.
got money, getting stolen all the time. But
Yeah.
I think the difference is with the DAO is that it was open.
Yes.
It
The
was
door was
transparent, and
Yes.
everyone could see. So as soon as we could see the ether being drained, they didn't hide it. They didn't close it down
Right.
and stop the world from seeing it.
Right.
They went, we just got to let this.
Oh.
We've got to let the community
Let the wind
decide,
blow.
and that is the difference between what exists in the way we do business right now
Right.
and what that future that was offered to us. Yes, it didn't work, okay, but nothing is foolproof.
It's the cost of learning.
What did you want to say?
I wanted to pick up the point where you said that we are missing the point in that we're focusing on the DAO too much, and it could come into be regulated, and we should be moving away from that into a bigger idea for the blockchain.
Yeah.
With that, like if the DAO was to be regulated, would that not trigger that? But because the ideology for many people that are coming into it is that it is distributed, if you had
Decentralized.
if you had a centralized regulation, would that not just kill it? So therefore,
would for some
if
people.
that's the theory,
Yes.
if that's
Yeah,
where
for some people, yeah.
if that's where it's headed, then isn't it imperative that we then look at something else, whether it be the UN or something else?
Decentralized healthcare or other solutions. Yeah.
Yeah. So do we not have to get away from that? That's potentially coming.
If the DAO was to be regulated, you can't just only do the DAO, because this decision's being made by Ethereum, not just the DAO. Obviously, Ethereum's reversing this transaction. If you try to regulate only the DAO, it's going to outreach further, just by the way it is.
Would regulating the DAO turn it into the cow, the centralized autonomous organisation? Is that a possibility?
What were your thoughts on, you mentioned a couple of at the
There's
end,
a t-shirt, Alex.
social media with some new language and some other